A Laplace transform is an integral transform that is named after its inventor, Pierre-Marquis Simon de Laplace. We use Laplace transform as an alternative to differential equations when we are solving for linear ordinary differential equations, and most likely, majority of the applications of Laplace transform are more on electrical and electronics. So, the definition of Laplace transform is given by the integral equation that if we are taking the Laplace transform of a function of t, where t is actually a real variable that is often in terms of time, this is simply done by taking the integral of the product of e raised to negative st multiplied by that particular function of t dt, taking the limits, taking the definite integral from 0 to infinity. After applying this integral, the answer of the Laplace transform will become a function of s. So from a real variable t, Laplace transform makes a real variable t into an equation of a complex variable that is applied on electrical and electronics, most likely about frequency. Okay. For example, if our function of time is in terms of a constant, if we're going to take the Laplace transform of any constant c, applying the formula, we will have an integral from 0 to infinity of e raised to negative st multiplied by the constant, which is our function of t, dt. Applying this, we'll be able to have an answer that is the constant multiplied to the integral of e raised to negative st. So that would be negative e raised to negative st all over s. Applying the limits, applying the definite integral with limits of 0 to infinity. Therefore, we have 0 to infinity. But since we cannot substitute an infinite value directly, we're going to let another variable in place of infinity, let's say b. And then we'll simply take the limit of this function as b approaches to infinity. And we know the basic rule of limits, that is simply to substitute the value of b as it approaches to the infinite value. So if we're going to apply the limits, we will have an answer that is equivalent to the limit as b approaches to infinity of c multiplied to applying the upper and the lower limit in place of time. Since time is our variable, we have this could be written as negative 1 over s times e. This will become positive kasi bababa na natin siya. Then applying the limits again of 0 to b. So this will further become limit as b approaches to infinity. Our constant value c multiplied to, okay, we have negative 1 over s e raised to, applying upper limit in place of time, so we will have s times b minus lower limit negative minus negative 1 over s e raised to s times t, which is 0. In this case, since we cannot substitute infinity directly doon, ano nga po? If If we're going to take the limit as b approaches to infinity, if b is an infinite value multiplied to another constant value s, that means we are taking the quotient of 1 divided by e raised to an infinite value, which definitely will be infinite. Thus, this will be 1 divided by a very, very large number. Therefore, it would be approximately approaching 0. So, if we have 1 divided by 1 billion, that would be 0.0000, etc., which means it's approximately equivalent to 0. Therefore, this particular term, as b approaches infinity, approaches 0 as well, taking this as 0. Minus, that will make that positive. S times 0 would be 0. E raised to 0 would be equivalent to 1. So this particular function will be equivalent to 1. Therefore, this will be positive 1 over s. So if we're going to take this particular limit, the answer for the Laplace transform of c will be equivalent to c multiplied to positive 1 over s. Therefore, the Laplace transform of a constant is c over s. Halimbawa, kumukuha tayo ng Laplace transform ng t lang, variable t. So, if you're going to apply in place of f of t with t, magiging integral from 0 to infinity ng e raised to negative st times f of t, which is t, dt. This may only be solved by integration by parts. So if we're going to are going to apply integration by parts, recalling the formula of IBP, we have the integral of u dv, that would be equivalent to uv minus the integral of v du. Ibig sabihin, maglilet tayo ng u, and as a rule, if we have an algebraic term which is t, and an exponential function which is e raised to negative st, we're going to let u be equivalent to the algebraic term. Therefore, u is equivalent to t, and in this case, dv will be equivalent to u dv e raised to negative st differential with respect to time. We're going to take the differential of u, and that would be 1 dt. And then we're going to take the integral of dv. The integral of dv is v. And we're going to integrate e raised to negative st. So definitely that would be 1 e raised to negative st all over s. Okay. Applying the formula in solving for the integral, we have u times v. So u times v. T times negative e raised to negative st all over s plus minus the integral of v, that's negative, so this will become positive na, e raised to negative st over s du dt. Still limits from 0 to infinity, which applies to this term as well. It should be applied with the limit of 0 to infinity, which, kanina, ginawa natin dun sa Laplace transform of c. Nilet natin yun as b. And then, ang ginawa natin dito is, we took the limit as b approaches to infinity. Okay. So, mag-apply tayo ng formula dito. Same lang to nito, actually. So, So this will be written as the limit as b approaches to infinity of the term t so negative t e raised to negative st all over s. So, lalabas natin si 1 over s. 1 over s. I-integrate natin si e raised to negative st. And that would be negative e raised to negative st all over s. Applying the same set of limits from 0 to infinity. So, ang gawin natin dito, samahin na natin yung dalawang term. And that would be from 0 to b. So, ayusin natin ang itsura ulit. Pwede natin itong isulat as the limit as b approaches to infinity. Pwede nating i-factor out si e raised to negative st. Labas natin siya ito. Tsaka ito common. So, pwede natin itong ilabas. Multiply natin yan with negative t over s. Positive, negative, so negative ulit. 1 over s squared. Limits from 0 to b as b approaches infinity. In the same manner, gaya ng ginawa natin kanina, to be able to realize the effect of the infinite value, baba natin to make this positive. So, this will be limit as b approaches to infinity of 1 over e. Positive na yung exponent niya. Sorry, times negative t over s minus 1 over s squared. Again, limits from 0 to b as b approaches to infinity. So, if we're going to apply these limits, magiging ganito yung tsura na ito. Limit as b approaches to infinity. So, applying upper limit into this, we have 1 over e raised to sb times negative b over s minus 1 over s squared minus the effect of the lower limit. So you have 1 over e s times 0 minus 0 over s times negative 0 over s minus 1 over s squared. Applying the limits as b approaches to infinity. Again, this is an infinite term. So, 1 divided by an infinite value. This is already 0. So, 0 divided by any number will still be 0. So, this term is already 0. S times 0 will be 0. E raised to 0 will be 1. So, 1 over 1 is equivalent to 1. So, this one is 1. This one is 0. Kaya we have this term which is 0 minus the quantity. This is 0 na. Negative 1 over s squared. Therefore, we have positive 1 over s squared. Thus, the Laplace transform 1 over s squared as the Laplace transform of t. This is our formula. This is our third example. So, kung ang isosolve naman nating Laplace transform ay exponential function a raised to a which is a constant times t. So, pwede siyang e raised to 2t, e raised to 4t, e raised to negative 5t. To be able to solve for the Laplace transform of e raised to at, we will apply the same formula. So that would be integral from 0 to infinity of e raised to negative st times our function of time, which is e raised to at dt. Okay. Applying laws on exponents kasi same base ito. From 0 to infinity. Ano po? We're going to copy the base. And then we will have negative st plus at dt. This could instead be written as, igaya natin to dun sa kanina natin na there exists an exponential function with a negative exponent para mamaya pag nag-apply tayo ng limits, pwede natin ulit siyang ibaba. So, ang gagawin natin, we will have e, maglalabas tayo ng negative term, that will be we can factor out negative 1, magiging positive na to, this will become negative. At the same time, we can also factor out the same variable t. So, we'll have positive s minus a. Pinactor out si t. dt. Therefore, kung kukuha tayo ng integral ng e raised to negative s minus a times t, that will be equivalent to negative e raised to negative s minus a times time all over coefficient of time. That's s minus a. So, applying the limits from 0 to infinity, which will let us be, and then we'll simply take the limit of this function as b approaches to infinity. Okay. So, isusulat natin to. Pwede naman siyang ganito. Limit as b approaches to infinity. Since ito lang naman yung may function of my variable t, pwede naman natin ilabas yung ating constant accompaniment. So, magkakaroon tayo dito ng negative 1 over s minus a times, we can say na ito ay 1 over e. To make this positive an exponent, so we have s minus a times t. Limits again from 0 to b. So, kung mag-apply na tayo ng limits, we have limit as b approaches to infinity of, let's apply upper limit. So, we have negative 1 over s minus a times 1 over e s minus a times b minus 1 over e raised to s minus a times 0 naman. In place of time. So, kung i-apply natin yung limit as b approaches to infinity, this is an infinite number. So, mangyayari dito, this will be an infinite value denominator. So, 1 divided by infinity. That will still be counted as 0. Minus a times 0 is 0. We have e raised to 0, which will be equivalent to 1. 1 over 1. This one is equivalent to 1. Therefore, the function will be negative 1 over s minus a times 0 minus 1, which make this negative 1 times negative positive. Our answer will be 1 over s minus a, where therefore the Laplace transform of e raised to at is simply equivalent to 1 all over s minus a. Okay, so there are also Laplace transform of trigonometric functions or combinations of exponential and trigo or algebraic and exponential and so on. Hindi natin derive yung ibang yun. So, since there are common functions in Laplace transform, meron tayong nabuo na derived formulas for the Laplace transforms of several f of t's. So we started the derivation with constant. Our answer was constant over s. We also took the Laplace transform of e raised to a t using the integral formula, and our answer was 1 all over s minus a. We took the Laplace transform of t. We were able to get an answer of 1 over s squared. Therefore, if you're going to take the derivation of several functions, let's say for example, you have t raised to n to n, where n is an exponent, n exponent, and a real exponent. So we have n factorial all over s raised to n plus 1. If we're going to take the Laplace transform of cosine kt, s over s squared plus k squared naman siya. For sine kt, that would be k over s squared plus k squared. So as you can notice here in these two examples of trigo, k is a coefficient of t as an angle. So kapag cosine, s ito. Kapag sine, k naman yung numerator. But they apply the same formula for the denominator. So as an illustrative example of the formulas, if we're going to take the Laplace transform of 3, which is a constant, the answer will be 3 over s. If we're going to take the Laplace transform, let's say for example, of e raised to 2t, that would be 1 all over s minus a. A is the coefficient of the exponent. So s minus 2. We'll take the Laplace transform, for example, of e raised to negative pi t. That would be 1 all over s minus, again, a. But a here is negative pi. So minus negative pi, that will make it positive pi as an answer. Okay. And this is direct, that the Laplace transform of t is of course 1 all over s squared. But if we will be asked for the Laplace transform of t squared, we'll apply this formula. So that will be 2 factorial all over s raised to 2 plus 1. Therefore, we have 2 factorial of 2 times 1. That will be 2 all over s cubed. Or if instead we have the Laplace transform of t raised to 5, therefore we'll have 5 factorial all over s raised to 5 plus 1. So we have, ano ba ang 5 factorial? 32 over s raised to 6. Okay. If we have the Laplace transform of cosine t, now it would be s over s squared plus 2 squared. So we'll have s all over s squared plus 4. If we're going to take the Laplace transform of sine pi t, we have pi, kasi k ito. So kung ano yun, pi all over s squared plus pi squared. So this is our table. Okay. Aside from this, 1, 2, 3, 4, 5, 6. Aside from these 6 functions, we still have 2 that are about hyperbolic functions naman. So to write them down, I'll remove this example. So if our f of t naman is hyperbolic cosine kt, its Laplace transform is equivalent to the same numerator with cosine. Ano po? So, kung hyperbolic cosine, same cosine sila. S pa rin ito. Ang difference from trigo to hyperbolic is, this is positive, dito negative siya. So, kung sine, hyperbolic sine kt naman, same numerator with sine, k pa din. Pero the denominator will, sa halip na positive, negative siya. S squared minus k squared. Kaya pag tinanong tayo, Laplace transform of hyperbolic cosine t, that would be s all over s squared minus the coefficient of t, which is 1. So, 1 squared is still 1. Pag Laplace transform naman ng hyperbolic sine hyperbolic sine e times t, that would be e, the coefficient of the angle, all over s squared minus e squared. Therefore, ito yung ating 8 common functions for Laplace transform.